Okay, my friends, so we've got a paper here by the Substance Abuse and Mental Health. I forget what SAM HSA stands for. It's a governmental agency that basically is designed to study mental health and drug use in the country. And I fully support the first sentence here. Mental illness is a major public health concern in the U.S., as is drug use and drug abuse. But I'm not here to talk about the context of this paper. I'm here to talk about the reporting in this paper. So what we're going to do is going to scroll down here, and we're going to find the confidence intervals. So what they've done is they've got, so table 1 doesn't have intervals yet. We'll talk about this real quick. It's got any mental illness in the past year among people aged 18 or older. So these are clearly statistics, because there's no way they looked at every single person. These are diagnoses of mental health. As one of the problems with the mental health situation in this country is there is much undiagnosed mental health issue going around. So we're going to go down and we're going to actually take these and turn them into, here we go. Now we got them into confidence intervals. Okay. So please notice what they've done is they've done 95% confidence intervals. It looks like they've done them actually for 2 age ranges, 2010 to 2012 and then 2012 to 2014. In other words, they've got a lot down here. They've broken it out for every single, every single state. Yep, so we've got 50 states plus 4 regions times 2. So what is that? That's 54. That's 108 confidence intervals. 108 confidence intervals. Now, I want you to notice 2 things. The first thing is that there's 108 confidence intervals. The second thing is that they're all at 95% confidence. So let's go to the board and talk about why this potentially can be an issue. Okay, my friends. Let's talk about the problem with repeatedly stacking confidence intervals like that. Let's say you have 1 confidence interval. Confidence interval number 1. And it doesn't matter what the actual interval is. What matters is the fact that it's at 95% confidence. Now, remember what that means. You drew a random sample from a population. That means you have a margin of error around whatever statistic you got. Which also means you're not 100% certain you caught the parameter. You're only 95% certain you caught the parameter. Which means out of every 100 confidence intervals drawn from that population, 95% of them, 95 out of the 100 of them, will have trapped the true parameter. Is that 1? Well, by the definition of probability, you've got a 95 out of 100 shot that that's 1 of them. So one way to think about it, and I know pure statisticians hate when I say this, is whenever you form a confidence interval, you've only got about a 95% chance that you caught that parameter. You don't get into a fist fight with statisticians about this. They get so pissed off when you say that. But that's really what it means. Are you one of the ones that caught the parameter? Well, that means you're one of the 95 out of 100. That's 95% chance. Okay, now, here's the problem. Once you add a second confidence interval, which is also at 95% confidence, both of those together are no longer pairwise at 95% confidence. Because here's the deal. The chance this one caught the parameter is at 95%. The chance this one caught the parameter is also at 95%. What's the chance that both confidence interval number 1 and confidence interval number 2 caught the parameter? Now, depending on what course you came out of before Stats 243, you may or may not have learned this, but you're going to learn it right now. The chance that both of them caught the parameters they're looking for is equal to 0.95, which is the chance you caught it in the first one, times 0.95. So there's a 95% chance you got it in the first one, and a 95% chance you got it in the second one. And in probability means multiply. It's not a big part of this course. It used to be before the state changed it. I'm not going to go down that rabbit hole of blame game again. But and means to multiply. So if you're only 95% right in the first confidence interval and 95% right in the second confidence interval, that means you're only about 90% right. I think it's, if I remember correctly, it's 90.25%. 90.25%. What if you get a third confidence interval involved? I think this is a time and place for a spreadsheet. Okay, my friends, so let's set up a spreadsheet to help us answer this question. We're going to make the left column be number of confidence intervals, each at 95%. Okay, we're going to make that column. We'll start with 1, like we already had, and then we'll go to 2, we'll go to 3, we'll go to 4, we'll go to 5, and so forth. And we'll let this go. Actually, we'll stop at 2 for right now. We'll just extend it down as we need to. And then we'll look at the overall confidence of all the intervals. Overall confidence of all CIs. Okay. Now, this one here, actually, let's put the third one in just for sake of argument. This one here is going to be 95%. I'm going to make it 0.95 just because I like doing math on decimals and not percentages. We can always change it to a percent later. Okay, we just said this one with 2 confidence intervals is going to be equal to the product of 0.95 and 0.95, which ends up being that 90.25% that I just mentioned on the board. Somehow I kept that in my head. How about with 3? Well, with 3, it would be 0.95 times 0.95 times 0.95. And that goes down even further to about 85%, 86%. So you can see if you continually stack intervals in, 4, 5, 6, the confidence overall keeps getting worse. What does that mean? That means the chance that at least one of them misses is going up. Remember, this is the chance that they all catch the parameter. What's the chance at least one misses a parameter? I spelled parameter and chance wrong. Hang on a second. Chance that at least one misses a parameter. Well, the chance that at least one misses a parameter is whatever's left. 1 minus this. Whoops, forgot the equal sign. Equals 1 minus this. And that just keeps growing the more intervals we have. Now, we're going to continue this down to show you how ridiculous listing 108 confidence interval was in that paper. But we need a formula here. Please notice that this is 0.95, this is 0.95 squared, this is 0.95 cubed. Really, what these formulas are it's 0.95 to the power of that. And once again, I forgot the equal sign. Really what it is it equals 0.95 to the power that's over here. And if we can drag that thing down. And now what's cool about this is we can drag it way down to 6. So you can see by the time you get to 6 intervals, you're only 73% confident, which means you're about a 25% shot you're going to miss in at least one of those intervals. Now, you probably want percentages, don't you? I bet you do. So let's change these to percentages. That probably make you happier. Now, let's continue this down all the way to what it was in that article, which was 108 individual confidence intervals. Okay, there's 108 of them. Okay. Now what we're going to do is we're going to copy this all the way down. This is the overall confidence of all the intervals depending on how many you have. By the time you get down to 108, now it's not really 0%. It's not that bad, but it's pretty bad. The chance of all of them correctly trapping all the parameters they're trying to trap is less than 1%, which means the chance, as you know, the chance of at least one of them missing it, goes almost to 100%. It's not really 100%, it's 99.6%, but still, you can see the problem. This is the problem. I mean, heck, you probably knew this was going to be a problem based on the quiz you looked at a couple weeks ago when we were looking at 20 intervals at a time. Remember we were looking at 20 of them? Trying to establish what 95% confidence means? It means on average one of them misses. There's only a 36% chance that all 20 are going to catch it. That means you're twice as likely to miss with at least one. So how do you fix this problem? I'm going to give you 3 answers. 2 kind of flippant, not really, statistically flippant, I guess. And the third, we'll deal with it mathematically. Okay, first of all, don't ever list out hundreds of confidence intervals like that. That's just inviting error. I mean, you just saw why. That's the flippant answer number 1. Flippant answer number 2. There are statistical tests. We will not learn them in Math 240 or Stat 243Z. We used to learn them in Math 244, called goodness of fit tests. I'm just going to mention those now, and that way if you're ever looking at these videos later on in your careers, you'll at least hear that reference, or you'll just Google it and you'll see goodness of fit tests are a way of not losing confidence when looking at multiple proportions. But the way you can deal with them using the methods from this course is almost an undoing of what we just did. Remember what we said? With two confidence intervals, both at 95% confidence. The problem is the overall confidence shrinks. It shrinks because if they're both at 95%, then 95% squared shrinks to about 90.25%. That's a problem. So the overall confidence that you desire is only here. Well, what if we desire 95% overall confidence with two intervals? Well, they clearly can't be at 95%. They clearly have to each be at a higher percent so that when we multiply them together, we knock it down to 95. So in other words, what confidence does each interval have to be at? Well, I don't know. So I'm going to call that x. So we got to find a number x such that x times x equals 0.95. And I'm going to leave that as an exercise in your homework. And then I'm also going to have you do a couple more like this, just to practice. Little tiny bit of algebra. Little tiny bit of algebra. And you don't even have to do it with algebra. What some students do, I'll just give you a hint, they just keep plugging numbers in there until that comes out. But there is a quick little algebraic, it's not even algebraic, it's arithmetic. There's a quick little arithmetic move you can use. Okay, so that is a potential problem with using too many confidence intervals, but this is the solution. Just change the confidence so that it's high enough and then run the interval again. And I'll have you do that in the homework too. Okay, one more video to wrap up confidence intervals on proportions, and then you're ready to go.